Okay, on number 5, in a triangle, all the angles must equal how many? 180. But then I can be even more clever and say, well, if I know that is 90 degrees, can I just add these two and equal that to 90? So if you want to avoid working with big numbers, you can do that. But you don't have to. So when I combine like terms, we have 7x plus 6 is equal to 90. What is 90 minus 6?
84.
84. And can 7 go into 84 clean?
12.
How many?
12.
And it says to just find x, so we're good to go.
That adds 2.
12. Did I just write 2?
Yes, sir. Yeah.
I guess happy Friday to me, right?
Yeah, you did.
All right. On number 6. Y'all remember the exterior angles theorem?
Yep.
When I add these two, remote interior, add these two, must equal the outside. So when I do, I get 20x plus 6 plus 18x must equal 132 minus 4x. And then let's combine like terms. If I get 20x and 18x, that's 38. Are you guys okay if I go ahead and subtract 6 on both sides?
Yes.
Okay, so that's going to give me 120, how many?
6.
6. And now let's add 4x on both sides. That is 42x. Can 42 go into 126 clean?
Yep.
How many?
3.
3 times. But then on this one, it didn't just say find x. It says to find angle DFG. So DFG is right here. So could I find the measurement of the angle of this linear pair and then subtract it from 180?
Yes.
Yep. So how many was 132 minus 4 times the 3?
120.
So this was 120 right here? So that makes this angle 60 degrees. So measurement of angle DFG, that's an F, is 60 degrees. What else could I have done if I had a brain fart? Plug it into angle D, plug it into angle G, and subtract it from 180 also. Okay? So now let's go on to the proof part. Oh, not the proof part. That's the next part. Number 14 first. Okay, on number 14. If it is sometimes, how many examples should we have? 2. If it is always, how many examples? 1. If it's never, can you make one?
Nope.
Nope. So an isosceles triangle is always, sometimes, or never an acute. What do you guys think? Sometimes it is, and I'm going to prove that to you. So here I have an isosceles triangle. 2 sides are congruent. And here I have another isosceles triangle, really wide. That angle must be obtuse. I know the figure is not drawn to scale, but if I were to fill in some numbers, I could make that 100. I could make this one a 40 and a 40. So therefore, it's going to be sometimes. Okay, Chris, let's read the second part, and you don't have to fill in the blank. So if I tell you 2 triangles are congruent, and they're both right triangles, would the hypotenuse be congruent as well? Yes. And here's my example. Here I have a congruent right triangle. These 2 are congruent. Then do I know that these 2 are corresponding parts? Yep. Okay, Henry, let's read part C.
The hypotenuse and the length of one triangle are never congruent.
Because if the hypotenuse is the longest side and the leg is not the longest, they could never be congruent. Never.
You have other right to do.
All right, let's go on to the proof. Number 17. Okay, on number 17, let's start by writing out our first given. So we have angle BFE is congruent to angle BDE by the what? Given. Let's go to notate. Here's BFE, and here's BDE, and I'm going to write A as an angle. The second given is segment bisector or angle bisector. Am I cutting an angle in half or segment? Angle. And I want you to write angry big cat. So angry big stands for angle bisector. That's our given. So BE bisects angle FBD. So if it's cutting this angle in half, that makes these two angles congruent to each other. So C stands for congruency. Can I name those two angles as just angle B? No, it's got multiple angles being shared. So I need to be specific and say angle. I'm going to go from FBE. How would I write that consistently for the other side? DBE. Very good. DBE. I forgot to write the given. By definition of what bisector? Angle bisector. Let's write A up here. And when the third information is not given, it's almost always vertical angles are congruent or reflexive property. What do we have on this one? Reflexive. And that is a side. So I'm going to say BE is congruent to BE. Reflexive property of congruence. So let's highlight this consecutively. Here I have angle, angle, side. Why can't I say angle, side, angle? Between this angle and that side, I'm skipping two things, okay? So let's go ahead and name this triangle. FBE. FBE is congruent to triangle. How would I name the other triangle to be consistent?
DBE.
DBE. By angle, angle, side. I guess congruence will be fine too. You don't have to have that part. So we know our final goal has to go on number 7. So let's write that out. E is a midpoint of FD. So then if I want E as a midpoint of FD, what two sides must be congruent? FE must be congruent to DE. And that was on 4.6 lesson. What was the acronym?
CP.
Corresponding parts of congruent triangles are congruent. Okay? And a way to kind of remember is every other, it starts with a C and every other is a C. And that would be definition of midpoint.